So turning points are exactly what they sound like. It's where you turn. Okay, so if you're increasing and you decrease, you've turned. If you're decreasing and then you increase, you've turned. And then where you've turned, these points where you turned, are either a local maximum or a local minimum. And they're local because, like, if you look at this polynomial, there is no maximum or minimum because they go forever in these directions, right? So we're looking locally. All right, so a local maximum, local minimum is what we have. All right, so this is probably a fill in the blank. So you can take a minute, you can pause the video or whatever you need to do. But that's exactly what the turning points are. Okay, so let's talk about some interesting facts about turning points. So the graph of every polynomial function of degree n, okay, so it can be any number, has at most n minus 1 turning points. So let me give you an example. This is number 1. So let's say I have x to the third plus blah, 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 okay? And it looks like this. How many turning points does it have? 1, 2, right? It can't have any more than that. If it turns again, then it's going to be an x to the fourth. But an x to the third can also look like this, right? And how many turning points does that have? None. Okay? Now, the second rule says if a polynomial function of the degree n has n distinct real roots. See, this one only has one. It only has one real root. If it has exactly the same amount of roots as its exponent, as its highest exponent, then it has exactly n minus 1 turning points. Okay, so let me show you what I mean. Say we've got x to the fifth plus, I don't know, blah, blah, okay? It could be this big long thing, but it's still x to the fifth something. All right, so it's got to cross, it's got 5 real roots. It's got to cross the x-axis 5 times. 1, 2, 3, 4, 5. How many turning points does it have? 1, 2, 3, 4. Okay? It can't have any more, it can't have any less. But that's only if it's got all those real roots. Okay? All right. So let's look at a couple of examples. How many turning points does this function have? Well, first of all, we should notice that it's x to the third power. And I know that it has 3 real roots because I can tell you what they are. -2, 1, and 3. So it has exactly 2 turning points. 2 toilet papers. Maybe I shouldn't put that. It has 2, okay? All right, this one, I don't know how many real roots or imaginary roots it has. So I'm asking, the question is, at most, how many turning points does it have? Well, it's of degree 6, so I know that at most, it could have 5. If they were all real, it could have 5. Chances are that it doesn't. As a matter of fact, I actually put this on Desmos, and it kind of looks like this. It's kind of weird like this. So it actually only has 2. It actually only has 1 turning point. Just kind of interesting. But anyway, all right. Moving on. Okay, we've talked a lot before about increasing and decreasing with parabolas. And we still talk about increasing and decreasing with polynomials. It just gets a little more involved. So say we have this function, and we're talking about where it's increasing and where it's decreasing. So increasing, and here we'll use tint view colors. And decreasing. So again, you have to kind of think of this like a roller coaster. So here it's coming, we're increasing, and then it's coming down, decreasing, and then increasing forever. Okay, but where is it coming from? Where is it increasing from? Okay, and you also need to remember that we're coming along the x-axis. So we're coming from no man's land. This is negative infinity. And where does it stop increasing? It stops increasing right here. I mean, I know it looks like it's here, but we're looking at the x-axis. So it's 0. And this is where it starts decreasing at 0, okay? And it stops decreasing right here at 2. And that's where it starts increasing again, and it increases into no man's land going into infinity, okay? Now if you want to, you can write it this way: x is less than 0, x is greater than 2, and here you can say 0 is less than x, which is less than 2. So x is sandwiched in between there. So if you want to do that, you can. All right, I have messed up my stopwatch. Hang on, I got to check the time really fast. I can't really go over 10 minutes with this. All right, so I really only have one more video in this lesson, but I gotta cut this right here. So I'll finish up in the next video.